Okay, and welcome to another interview with Oleg and this time Heinz Kabutz, fresh off a VJug session called the Live Reflection Madness. So just a little bit about Heinz. We talked about some of the things that Heinz does, a couple of things. From Sunny Crete, Heinz does some Java training, so if you're interested in some top masterclass training, and also catching some rays in Crete, go to javaspecialists.eu and you can sign up and see some of the sessions. One of which I believe is a Java concurrency session in April, and also some there's a Java specialist newsletter which has almost been going 15 years, written by Heinz, which comes out every month. So feel free to subscribe to that again via javaspecialists.eu. So welcome Heinz, and also welcome Oleg. No problem. Over to you, Oleg.
Great, thanks, Simon. Hello, Heinz.
Hi, Oleg.
It's always a pleasure to talk to you, and this was a great virtual jug session. So let's jump straight into the short interview that we'll publish on Rebel Labs, which is a blog platform for zero turnaround. So we'll start with quick questions, like basically yes or no. So what do you think? Is computer science a real science?
Is computer science a real science? You're not asking me that, are you?
I am asking you. No, it's just a yes or no. You don't have to elaborate. Just your opinion.
I'm going to just shake my head at that question. I'm not going to answer that question.
Very sophisticated dodge. Okay, so static or dynamic typing?
Static or dynamic typing?
Yep. Personally, also.
I don't know. I like them both.
So, what IDE would you use, Eclipse, IntelliJ, or NetBeans for Java, of course?
Well, that's an easy answer. If I want to do a demo on a stage and produce code that is just magically appearing out of nowhere, and that I won't need to maintain afterwards, that I won't need to have a look at again, I can just delete afterwards, I would use NetBeans. If I want to hurt myself with 1,000 cuts, I would use Eclipse. And if I want to do real productive work, I'd use IntelliJ. And VI. Don't forget VI. That's also very important.
That works everywhere. So what do you think? What do you think? What is the worst thing a programmer can do? Just from the top of your head.
The worst thing a programmer can do?
Yeah,
I think the worst thing you can do is to code whilst under the influence of alcohol. So this one company I used to work for, I know you've got a pretty high tolerance, but let me just finish the story, right? Because it's a good story. This one company I worked for, they had this policy, and I went for the job interview, and the guy offered me a beer, and I should have realized that was actually, it wasn't a test, it was like the company culture. And what happened is, every day after 6 o'clock, they gave free beer to anybody who was still there working. So you can have as much as you want, just help yourself to free beers. And I'd get in the morning and go like, oh my goodness, what happened here last night? You see all these like beers and beer bottles everywhere.
Well,
the code those guys produced after hours was just unbelievable. So if you're a programmer, the worst thing you can do is program whilst being intoxicated. Yeah. Don't do it. Don't program drunk.
Maybe that would work.
Don't let your friends program drunk. There's sort of a level where you actually are productive. It's like 1 or 2 beers. It's actually good for your programming. But then beyond that, it just goes woof, like really far down.
Yep. Well, it also depends on some attributes of your programming career. If you're doing something like Haskell or something that has a really nice safety of type system, then maybe you can get 1 or 2 beers. If you're doing PHP, then you're probably a better sober.
PHP, you do not want to do that drunk. That's going to be a real problem.
So, while we are at the languages, what is your favorite JVM language?
You know, I don't like any of them, to be honest.
Even
I mean,
just plain Java?
I know that's just horrible. I mean, Java's a horrible language. It's just the syntax is really ugly. Scala is so weird. I mean, you sort of have these funny symbols, and you can write code in Scala that really only what's that guy's name is Martin can understand. That's about it, And what I've noticed when I first started teaching programming professionally, not I did my PhD at university, and I went into industry programming and then the people I worked with, besides the alcohol abuse, actually were quite smart. They were very smart. The fact that our system worked at all was a miracle, and it wouldn't have worked with any other types of people. But what happened was I gave my first course, and I realized that the people who are typing away at keyboards, producing what they call code, really have got absolutely no clue at all about what they're doing. For the large majority of, I mean, it's not true everywhere, but there are just so many people who just don't have a clue about anything to do with programming. I gave them a simple assignment: write a recursive function. They looked at me with big eyes, going like, what is reflection? You're like, you don't know what that is? You serious? You really don't know what that is? You must be joking. And they really had no clue about anything that wasn't related to their particular field of interest. So, yeah, not even business domain. Just software engineering. That's why I dodged your question. That's like that doesn't exist. And so my point was that in my experience, programmers find it easiest as a whole when you can look at a piece of code and you can sort of see what it does. That's why reflection is difficult, because you see it and you've got no clue what it's going to do. It's why I think that Scala can be absolutely brilliant. It can be very, very nice to read, but it can also be just, the way they do generics extends or supers, it's like, come on, it's very difficult. Unless you're 100% a Scala programmer, you've got no chance. Whereas if you don't know Java, let's say, for example, you've just done a bit of C++, or maybe some C# or something else, and you look at Java code, you actually can figure out what it's doing. Whereas with other languages, you've got no idea. So they might be more productive, but in terms of finding resources, and resource is a programmer, of course, Java is actually, the plain Java language is actually not so bad. I don't like it. I don't like the syntax. I don't like the way that it works, but I do understand that people understand it quite easily. I mean, I teach advanced Java classes. I haven't taught a beginner's Java class for many, many years. Nowadays, it's all like people who really are good at Java. They come to my class, and so it's a lot of fun because we have great discussions and great questions. Yeah, so that doesn't really answer your question. I know you're reading off a list of standard questions there, but
yeah, this is going a bit in a different direction that we usually do. But
it's some dumb questions.
It's really interesting. So while we are talking about the classes that you give and the issues that you uncover and publish in the newsletter, and you've been doing so, as Simon said, for 15 years now, almost 15 years. So do you think that the early releases, early issues of the newsletter are still relevant today, or did the Java landscape change beyond any comparison, and now probably like newcomers would be better off starting somewhere in the middle, not looking back at those weird concurrency issues in Java like 5 or something?
I don't know. I've had some really weird things happen to me. Like I would look, somebody would send me a question about newsletter number 20 or something, or 13, you know, from 14 years ago. And you know, when I was talking about the bugs being backwards compatible, I wasn't joking. They really are backwards compatible. And okay, so there's some weird stuff. I mean, dynamic proxies, that's still very relevant. I'm just looking at my list here. I don't know if you can zoom into that, but I mean, my very first one I wrote was about deadlocks.
Well, that's fundamental.
Yeah, absolutely. But how to find them, how to diagnose them, and we have moved on a little bit since then. But fundamentally, it still works in the same way. You basically get a thread dump. You look at the thread dump, and that will tell you where the problem comes from. So yeah, control break. You know, thread dump. It's I had, for example, a case. I was doing a course for Red Hat. You don't know if you know them, Red Hat? You don't know them.
Of course.
A small little company somewhere that do this thing called JBoss, and I don't know if you've heard of that. And they were trying to beat a benchmark. They had a benchmark, and what was happening is that their system was running, and then the performance would dip down, and it would stay down, and we couldn't get up again. And I was there, and I said, okay, good, guys, just do me a favor. Before the thing happens, they could sort of figure out when it would happen. Make 5 thread dumps. So we're talking about issue 001, right? Looking back at 2000. Take 5 thread dumps, then take another 5 thread dumps later on, and after the problem has started, and I'll look at them. And you know, the one evening I was sitting in the bar there drinking water, not beer, and I was trying to figure out what was going on in those thread dumps, and I found the problem. And the problem was that they were losing semaphores. You could see it in the thread dump. You could see these things. So we're going back. Okay, obviously a lot of the stuff is not relevant anymore, like logging, but anonymous in the classes. This was published in a book. Morris Naftaman wrote about it in his book. He claims that he's seen this in lots of other places before, but I would challenge anybody to find something that looks like this inside, you know, before this newsletter. That would be quite hard to find. I'll tell you something which is annoying. I sometimes look for stuff that I don't know, because there's also a lot of stuff that I don't know. So I'll go to Google and I'll type in there, for example, how can let's try, I'm going to do some random stuff now. Java, invoke dynamic, just anything, I don't know. And invariably, now this time it didn't happen, but invariably I'll find my newsletter somewhere in the first page. And I don't know the answer, which is why I'm typing it in. Let's say equals, I don't know, we'll just like equals.
It just shows that you have a great resource, and that information
it's over 200 newsletters, and I'm sort of going like, but this is not going to help me, because I actually want to learn something, and I can't find it on Google because I'm just putting me to my newsletter. It's really annoying.
Yeah, so, I can understand that sentiment.
Well, you know what makes it worse. What makes it worse is that I know that the answer is not in my newsletter, because I don't know the answer. So how can it be in my newsletter? Something like this Google is not very good because it's pointing me in the wrong direction.
Yeah, maybe so they need to improve.
I would sort of start at the most current ones, right?
Going backwards.
I'd probably start. I would go backwards because, you know, also I started writing nice descriptions for them, and I mean, managed blocker is going to be more interesting to somebody who's using Java 7 or Java 8 than you know, trying to put code inside interfaces, which was a little dirty trick I used in the past, which you can do quite differently nowadays. But sort of go back rather is a better way of doing it.
That's the same advice. And let's just go with one smaller question. You've uncovered and showed us a lot of complexity during the session, and there are even more in the newsletter that people can ponder around. So what do you think to handle all that? Do we need smarter people, or do we need to simplify the technology somehow? Or is it even possible? Or just like learn, study, and then we can get to the better place?
Okay, I think we've got smart people. I don't think smart people are the problem.
Okay.
But then maybe I'm meeting the cream of the crop. You know, the people that come to my courses are not the junior people. They are and the people that I meet at conferences are smart people. I don't think we've got a lack of smart people in the industry, personally. I think we have a lot of people in the Java business and in other businesses too, in other languages too, who are very smart. And I think Java is actually still quite simple. It's still something that you can look at. Pardon?
Java is very simple, and the simplicity was the virtue from the very beginning. So. It was a plan.
I think so.
I think Java did great.
So I'll give you one little example, if I can jump to code for a moment. Talk about this in my concurrency course. So let's say that I want to have a bunch of runnables that start within the thread at about the same time. You obviously can't be sure that it's exactly the same time, but you know, as close as possible. So concurrent starting runnables, as we're going to call it here. And what you do is you pass in a list of runnables. So it's going to be public void start together. It's going to be a list runnable jobs. And what you do is you say, you know, we want to start them together, right? So they're all. It's going to be something like this. You're going to say iterate through the runnables, right, for each job in the jobs. You're going to say new thread.
Yep.
They're now going to have a job that does this. You're going to have public void run. Wait for the others. And then you say job.run. Of course, because it's Java 8, we don't have to make it final anymore. And then you say dot start. So wait for those and you start. Right? Now, this is sort of my foundation here. Okay. Now, we've got in Java from Java 5 we had a class called countdown latch. Countdown latch is very easy to understand, but not so easy to use. Okay. Whereas a class like phaser is very easy to use, but not so easy to understand. So you can't get away from complexity. Your complexity is either going to be inside the language, in other words, the language is going to be complicated, or it's going to be inside your code base. It's going to be somewhere. You know, complexity is complexity. You can't really get rid of it altogether. So, so this is why I say that the countdown latch is very easy to understand. I mean, I can explain that in like 1 second. We make a countdown latch, and I want to make sure. Right, so it's making a countdown latch over here. The latch equals new countdown latch to jobs.size, or make it +1, so we can also have the main thread also be part of this fun. And then we simply say latch.countdown and latch.wait. Very, very simple, right? Then afterwards you'd say latch.countdown as the final one, and maybe put a little bit of a sleep in here just to, oh, that looks like a fun thread. .sleep, just a short bit to let them all start up and be all ready, make it a bit shorter to be ready to fly away. Okay, and this code here is okay, but now what about this exception, right? Now we've got to deal with this exception. So what do? I don't know. You can't throw it. We can print it. I mean, this starts getting messy here. So to do this correctly, if you want to do this correctly to start together, what you really want to do is over here, when you get the wait, if you get interrupted, you want to save that for later. That's what you actually want to do. You don't really want to, at this point, throw an exception and catch it and ignore it. You want to catch it and save that information for later. So you're going to be doing something like this. You're going to say Boolean interrupted equals thread.interrupted. Then you'd say while true. Okay, and you're going to say latch.await break interrupted equals true, and then before you exit again, you're going to say if interrupted. Then you're going to say thread current thread.interrupt. You can actually just do it on yourself because you. But I'll just do it like this. It's sort of this like we call it self-interrupt basically. You can call it self-interrupt. But if you interrupt, then you re-interrupt yourself again. And this is the way that we often do coding when we're working with interruptions. If you look, for example, in lock.lock or semaphore.await uninterruptedly or condition.await uninterruptedly, this is sort of how we do it. This is normally sort of the approach we use. And you can see that it looks pretty horrible. Okay.
It is.
And we also have to count the size +1 and so on. So it's easy to understand this stuff, but to use it is not so easy because now I've got to worry about this stuff. Let me keep this for now, and we'll just comment it out, and we'll, in fact, we won't comment it out, we'll just call it with countdown. That's just a different method name. And then up here, I'm going to show you the same code but with a phaser. So instead of having a countdown latch, we make a phaser. Now, this is a Java 7 class, so it's not completely new. It's been around for a while. And with the phaser, you don't need to count what the total number is going to be up front. You can simply say we're going to start with 1, which is going to be our main thread. And then over here, all of this stuff here, we can delete and say phaser.arrive and await advance. Does all of that for us. All done. And here we would say phaser.await arrive and deregister would be the best one. There's other ones would also work, but this is the best one to use. And so you can see that the code is now, it's doing what we did before, but just a single method call rather than this big blob of code, which is, I mean, you give this to 100 programmers, maybe one will get this right. Maybe one.
Maybe 0. Yeah, it's, well, concurrent code is really hard to manage and to write correctly and to actually reason if some code is correct or not. It takes skill and experience and knowledge.
Yeah, this is not even concurrent code. I mean, I wouldn't even call this concurrent code. This is just interrupt management. But even that, I've actually got a whole chapter on interrupt management in my concurrency course that I'm doing an April retreat. You can imagine that, and it's one of the toughest chapters. People really, it's not easy. It's really not easy to get this stuff right. Yeah. That's what I'm saying. 1 out of 100. But over here.
Sorry, it just shows that the complexity has to be somewhere, and indeed exactly. we cannot avoid that.
No, look. What I'm saying is that the complexity is here. It's inside arrive and await advance. This is where the complexity belongs. We don't want to see code like this. We want to see the code. You know, I mean, that's even worse. This is even worse. So whenever we can, we sort of rely on code which is actually been a bit more established, but a bit more proven, and which works, which has been tested. Of course, testing code is, you know, if you're interested in concurrency, it's a really good idea to join the concurrency interest mailing list. There are lots of great discussions on that. I've learned so much on it. And any new constructs, yeah, if any new constructs come out, then it's the concurrency interest mailing list. Any new concepts come out, they'll be talked about on that list first, and then from there, they'll be tested on the list too. So if you want to help test a new class, for example, the stamped lock that was released in Java 8, I took that for a spin. I found performance issues, performance bugs actually, with starvation. I found liveness issues with it. But then once we figured them out, we also found some better idioms to use. Once you figure that out, it really is a fantastic class. And
Heinz, I'm very sorry. Let's not go into the details of how stamped lock.
No, I won't. No,
yeah,
I'm not going to. I'm just saying that if you're interested in anything to do with concurrency, go there and you'll be able to be part of the discussion. Really interesting.
Yes, concurrency interest mailing list is a fascinating place. You
it is, yeah.
understand just a little, and then you kind of recognize words, and then you build up some knowledge, and it's a great list to follow.
Yeah, once you understand Roach-Motel semantics, then you're going somewhere.
Yes, indeed. So, okay, thank you for the knowledge that you shared with us today, and thanks for your time. It was great. Sure. So we'll publish the interview, we'll give the links to Twitter, and hopefully more people will educate themselves. So thanks a lot.
Thanks, Oleg. Bye-bye.